Hey there, welcome back to Max World. This is Sachin sir, and in today's lecture we are going to understand about lesson number 18, that is three-dimensional shapes. Before proceeding further, let's have a look at the meaning of 3D figures or solids. Very first, observe these diagrams. If you look them carefully, you will come to know that all these three diagrams, they have height, okay, they have length and breadth also, and all these three occupy space, and these features only make the 3D figures. So in short, we can say diagrams which have three dimensions, that is length, breadth and height, and which occupy space, are called as 3D figures. Let's try to have better comprehension or better understanding of this diagram. So boys and girls, these are the 3D shapes that we are going to learn in this lesson. These 3D shapes are divided into two main parts. The one which has straight edges and sharp corners, and another one which do not have straight edges or sharp corners. See, they are very smooth and they do not have a straight edge, right? The one which has sharp corners and the straight edges are called as polyhedron, and the one which do not, they are called as non-polyhedron. These diagrams, non-polyhedron, they are identified by special feature of having curved surface areas. Dear students, these polyhedron are again divided into two main parts. Very first is prism, another one is pyramid. Now let's try to understand the features of this prism first. Prism is a 3D diagram in which bottom and the top will be flat and they will be of same shape. See over here, if you see this 1, 2, 3, 4, 5, 6, this shape is hexagon, and even at the bottom also 1, 2, 3, 4, 5, 6, it is again hexagon. So the top and the bottom is hexagonal, and the side faces or the standing faces, see here, standing faces are rectangular, if you can observe, right? It is not only for this shape. Check out this one. If you look at the bottom, it is triangular, at the top it is triangular, means bottom and the top both are same, and the side faces, that means standing faces, are rectangular. So in short, for the prism, what we have observed that the top and the bottom faces are same. Standing faces are usually rectangular or quadrangular, you can say. Boys and girls, let's have a look at pyramids. Again, these are the 3D shapes. Now if you observe, the bottom of these 3D shapes are flat, right? But the top portion or the top face is not a flat one, it has a point, right? This tip of this pyramid is called as an apex. So this tip of the pyramid is called as an apex. Okay, so at the bottom we have flat surface or the flat face, but at the top we have a point. If you observe, all these standing faces of this pyramid are triangular. Not only for this, if you observe this one, this is the flat portion, and now this again, the standing portion is again flat but triangular. Same goes over here. At the bottom we have pentagon over here, right? And from each side, if you see, a triangular face is going upward and meeting each other, that all the standing faces are meeting each other at a single point, right? So for the pyramid, what we have flat portion or the flat face at the bottom, but all the standing faces are triangular and they meet each other at a single point at the top. This point, let's try to name these 3D diagrams. For the pyramid and the prism, the name always given according to the base of that diagram. That means if you observe this prism, the base is 1, 2, 3, 4, 5, 6, hexagonal. So I have to name it hexagonal prism. Check out this. This is pyramid. Just by looking at it, we should understand it, as the top is not a flat one. All these standing faces are meeting each other at a point, so it is pyramid. At the bottom of the pyramid, 1 2 3 4 5 6, 6 sides are there. That means it is a hexagonal, so we have to say it hexagonal pyramid. So this is hexagonal prism, this is hexagonal pyramid. Now observe this one, how many sides we have? 1 2 3 4 5. So this is pentagonal pyramid, and if you observe this, 1 2 3 4 5, 5 sides, that means it is a pentagon. So this is a pentagonal prism. This one over here, it has a triangular base, so this is triangular pyramid, or only pyramid if you say, will do. Now check out over here, this is cuboid. Okay, the base or the bottom is quadrangular, the top is flat, so it is a prism, quadrangle at the base, so I have to name it as a quadrangular prism. So this cuboid, this cube, this is also cube, all are nothing but this section, quadrangular prism. Now if you check over here, at the bottom we have triangle, but at the top we do not have a tip in this manner, right? So this diagram over here, it's a pyramid, triangular pyramid, but over here now it is triangle, as we have a flat portion at the top with the same base, right? Triangle, triangle, we have to name it as a triangular prism. So in short we can say prism and the pyramid are always named according to their base. Triangular pyramid, triangular prism, pentagonal pyramid, and this is pentagonal prism, and at last over here we have hexagonal prism and hexagonal pyramid. As we have understood the classification of these 3D figures in polyhedron and non-polyhedron, now let's try to summarize the details related to prism and pyramid. In prism, the top and the bottom faces are always same, whereas in pyramid, these faces are not equal because all these side faces, they meet at a single point at the top, and as they are meeting at a single point, the side faces or the standing faces become triangular, whereas in prism, these standing faces are always rectangular. In pyramid, the number of faces and vertices are always equal, whereas in prism, these number of faces and vertices are not same. Moreover, we also understood the name of the prism and pyramid is always depend upon the shape of their base, and according to base we have named a few of them. Now let's try to figure out the special features related to cylinder, cone and sphere, that is non-polyhedron diagram. Non-polyhedron diagrams are nothing but they have curved surface area. Let's try to understand this video. Now let's try to understand about the non-polyhedron diagrams, that is cylinder, cone, sphere, or this ball over here is also an example of a sphere. So all these 4 diagrams you can say are non-polyhedron. Why are they called non-polyhedron? First of all, for the non-polyhedron diagram, they do not have sharp corners or sharp edges, they have smooth curved part. Okay, smooth curved part, you can see over here, right? So this is the special feature for them. So for cone, for cylinder and for sphere, they have smooth curved part, so they are called as non-polyhedron. Now let's try to understand the features of this diagram. If you observe this cylinder, this is called closed cylinder. See, it is closed, nothing is open, right? At the bottom we have circular face, at the top we have circular face. So that means we have 2 circular face, and in the middle of these 2 circular faces we have a curved portion. This is called as curved surface or curved face. Okay, if you observe this cone, okay, again this is a closed cone. We have a circular base, right? Circular flat part at the bottom. We have smooth curved portion over here, right? A tip at the top. Again, this tip is called as an apex. Don't forget this. And if you observe this, it has circular edges also. For cone also we have one circular edge, and for cylinder also we have circular edge, right at the top and at the bottom also. So in short, we have circular face at the bottom and at the top. We have two circular edges again at the top and at the bottom, and one curved portion in the middle of the cylinder, right in the middle of these two circular faces. For the cone also same goes. We have one circular face at the bottom, circular edge at the bottom, right, and one vertex at the top. One vertex at the top. This vertex is also called as an apex. For sphere, if you observe, we do not have any of the vertex, we do not have any edge, no, like this circular edge is present. See, check out this ball. Now it is smooth, rounded one, right? It has no vertices, no edges. It has only one face, that is curved face, right? The smooth turning portion. So boys and girls, now it is time to write down the features that we have understood for these non-polyhedron diagrams. For cylinder, at the top and at the bottom, if you observe, there are circular faces. As there are circular faces, it makes two circular edges also, and it has one curved surface also. For the cone, the top of the cone or the tip of the cone is called as apex, and it has one circular edge at the bottom, one circular face again at the bottom, and one vertex at the top. For sphere, it has no edges, no vertices, and it has only one face, that is curved face. As these diagrams are non-polyhedron, they all have one curved surface. Now let's try to understand the features about the cube and cuboid, that is quadrangular prism. Girls, let's try to understand something more about quadrangular prism. It is not new for you. The dice you use while playing Ludo, you say, or snake and ladder, is nothing but the example of your this quadrangular prism. All these three shapes are quadrangular prism. These two are cube and this one is cuboid over here. How to identify them? If you observe this cube, you will come to know that it has 6 faces, one at the bottom, one at the top, and 4 standing, 1, 2, 3, and then 4 over here. All these 6 faces are squares, and for the cuboid, at the bottom, at the top, on a standing portion, you will come to know that it is made up of rectangles. So in short, cubes are made up of 6 square faces and cuboid is made up of 6 rectangular faces. Now let's try to count the vertices in these diagrams or in these shapes. For all these 3, the bottom is quadrangle, means there are 4 vertices, 1, 2, 3, 4. My dear, what vertices are the vertex for the quadrangle? Nothing but the point where 2 sides meet each other is called as a vertex. So over here, this one side meeting each other over here. So this corner is called as a vertex. So in that manner, we have 1, 2, 3, 4 vertex down and 4 vertices at the top. So 4 vertices down, 4 vertices at the top. So we have in short 8 vertices. Same goes over here with the cuboid. We have 1, 2, 3, 4 corners or 4 vertices at the bottom, and at the top again we have 4. 1, 2, 3, 4. So we have 8 vertices for this cuboid also. So for the cube and the cuboid, they have 6 faces, 8 vertices, and now let's try to count the edges. Edges means these lines over here, straight lines, standing lines, or over here slipping lines. Okay, now let's try to count them. At the bottom we have 1, 2, 3, 4. At the top again 1, 2, 3, 4 and 4 standing. So in short, 4 at the bottom, 4 at the top and 4 in a standing position. So in short, we have 12 edges for the cube. Same goes with the cuboid. At the bottom we have 4 edges, at the top we have 4 edges, and in the standing position again we have 4 edges. So in short, we have 12 edges for the cuboid also. Cube and cuboid both are quadrangular prism, So number of edges, vertices and the faces will remain same. The only difference lies in the type of faces they have. For cube, it has 6 square faces, 8 vertices and 12 edges. For the cuboid, number of vertices and the edges will remain same. That is, vertices are 8 and edges are 12. The only difference lies in the type of face it has. For the cuboid, it has 6 rectangular faces, and that's what we have for cube and cuboid. Now students, it is time to solve practice set 41 of the lesson 18. In this practice set, a list of 3D shapes are given to us and we need to write faces, vertices and the edges for those shapes. Very first one is cylinder and next one is cone. But before proceeding further, let's see this video and try to figure out faces, vertices and the edges accordingly. Now boys and girls, it is time to solve your exercise question. The questions are arranged according to shape: cylinder, cone, to pyramid and to prism. Okay, just by looking at the shape, we should be able to understand what kind of shape it is. These two are prism because their top and bottom are same and flat. These two are pyramid because bottom is flat but at the top they have pointed tip, right? These two are same. They are non-polyhedron because they have no sharp edges or straight edges or sharp corners, right? So these two are what? Non-polyhedron. These four are polyhedron. Okay, now let's begin us solving with the cylinder first, because the first question is of cylinder. I need to write faces, vertices and the edges present in this cylinder, in this 3D shape. Okay, so at the bottom we have one circular face, at the top we have one circular face, between these two circular faces we have one curved face, right? My dears, keep it in mind, this cylinder is called as closed cylinder. Okay, if you take a water pipe, then that water pipe will be open from both the ends, correct or not? Yes, at that time it is called as open cylinder. For the open cylinder, we do not have this circular face, isn't it right? Yes, we only have curved surface, and that is why for that open cylinder we will get only one face. But in this case, as it is a closed one, we have one circular face at the bottom, one circular face at the top, and between them we have one curved surface also. So we have in short 3 faces. Now let's think about the vertices. What sir said about the vertex? A point where 2 sides meet each other. Now for the cylinder, no 2 sides are meeting each other, right? So there is no vertex. Now let's think about the edges for this cylinder. Edges are means what? Sharp corners. Now do you think there is a sharp corner, standing one, straight one? No, but we have one circular edge at the top and at the bottom. So we have 2 edges, no vertices and 3 faces for the cylinder. Let's move on to find all these things again for the cone. For the cone, we have one circular base. Again, it is a closed cone. Okay, there is one open cone also. You might have seen or used also a birthday cap. It is hollow inside, right? So that cone, that shape is called as open cone. Okay, so over here it is closed, so we have one circular face at the bottom, we have one curved portion, right, and at the top we have a point, and it is not considered as a surface or the face. So we have only 2 faces. One is circular face at the bottom, one is curved face, right? For the vertex, yes, we have one vertex at the top because the sides are meeting each other at the top. One point is found over here, right? So that point is called as one vertex. And now edges I need to find. Again, we have one circular edge at the bottom, right? So we have 2 faces, circular at the bottom, curved face also over here. So 2 faces, one vertex at the top and one edge at the bottom for the cone. Now let's think about pentagonal pyramid. This pentagonal pyramid, boys and girls, now very first keep it in mind. If it is pyramid, okay, if it is pyramid, then at the top we do not consider any face because point is there. Okay, very first. Next thing, as it is pentagon, so 5 standing faces will be there for the pentagon. Penta means 5, hexa means 6, hepta means 7, octa means 8. Keep it in mind. I repeat again. Quadrilateral means 4 sides, Pentagonal means 5 sides, diagram with 5 sides. Hexa stands for 6, hepta stands for 7, octa stands for 8. Okay, so over here it is pentagonal pyramid. So pentagonal pyramid means what? From these 5 sides we will have 5 standing faces and 1 face at the bottom. So 5 standing, 1 at the bottom, so we have in short 6 faces, right? Now think about the vertices. We have 5, it's a pentagonal, right? So 5 point will be there, or the 5 vertices will be there at the bottom. 1, 2, 3, 4, 5, and 5 are down and 1 is at the top. So in short we have 6 faces, 1 at the bottom and 5 standing. 6 faces, again 6 vertices, 5 at the bottom and 1 at the top. So in short, faces and vertices for the pyramid will always remain same. Keep it in mind. What's I said? Faces and the vertices for the pyramid will always remain same. Okay, so we have 6 faces for the pentagonal pyramid, 6 vertices, and now let's think about the edges. See, edges means what? That corners, okay, that sides. So we have 5 sides at the bottom, right? From these 5 sides, or these 5 points, again 5 sides will move up, right? See here, 1, 2, then this 3, then this 4, then this 5. So 5 sides at the bottom, 5 sides moving towards point or the tip. So we have 10 sides in all, right? 10 edges in all. So for this pentagonal pyramid, what we have? 6 faces, 6 vertices and 10 edges. Okay, now boys and girls, let's try to find out just by listening to the name of the pyramid. Okay, now boys and girls, let's try to find out faces, vertices and the edges for hexagonal pyramid. Now let's try to calculate or estimate it just by observing the name of it. It's a hexagonal pyramid. It's a hexagonal means what? At the bottom we have 1 face, and as there are 6 sides, hexagonal means what? Hexa means what? 6, right? So as there are 6 sides at the bottom, so what will happen? 6 faces will move upward towards the apex or towards the tip. Okay, so 6 faces are moving upward and 1 face is at the bottom. So in short, we have 7 faces for this hexagonal pyramid. Okay, isn't it right? Check out now. For hexagonal, the 1 is at the base, and from every side, 1, 2, 3, 4, 5 and 6. From every side, one face moved up. That means 6 sides are there, so 6 faces moved up and 1 face is at the bottom. So there are 7 faces, right? Now let's think about the vertices. As there is a hexagon at the bottom, so we have 6 points. Hexa means 6, so 6 points are there at the bottom and 1 point is at the top. So in short, we have again 7 vertices. So in short, we have 7 faces and 7 vertices. Now let's think about the edges. Again, it's a hexagon, so 6 edges are already there at the bottom, and from every vertex a straight line is moving upward. So these are also 6 lines, right? I'm cutting from this thumb. 1, 2, 3, 4, 5, 6. So 6 edges moving upward, 6 edges at the bottom. So in short, we have 12 edges for hexagonal pyramid. So as a summary, we have 7 faces, 7 vertices and the 12 edges for this hexagonal pyramid. Now let's think about the prism. This is hexagonal prism. Okay, so let's think about the faces. We have 1 face at the top, 1 face at the bottom. It's a hexagonal, so from 6 sides, 6 faces will move up, right? As there are 6 sides, hexa means 6 sides are there. From every side, 1 face will move up. The way you are looking in this diagram or in this shape, this is a hexagon, this is 1 side, so 1 face moved up. Second side, so second face moved up. So in short, 6 faces will move up, 1 face at the top, another face at the bottom. So we have 8 faces in short for this prism, right? Now let's think about the vertices. There's a hexagon at the top, there's a hexagon at the bottom, so 6 point or the 6 vertices at the top, 6 vertices at the bottom, 6 plus 6, there are 12 vertices for this hexagonal prism. So we have 8 faces, 12 vertices, and now let's think about the edges for this hexagonal prism. Again, it's very easy. 6 corners or the 6 edges at the bottom, 6 edges at the top, and from point to point again 1 edge is moving, right? So in short, 6 edges moving upward, 6 above, 6 at the bottom, 6 moving upward. So 6 3s are 18. So 18 edges will be there in this diagram. So in short, we have 8 faces, 12 vertices, and 18 edges for this prism. Okay. Now let's think about this next one, pentagonal prism. Now boys and girls, without looking at this, we will try to understand it. Pentagonal prism, it is a prism, so we have one face at the bottom, one face at the top. As it is pentagon, means 5 sides are there. So as 5 sides are there, so 5 faces will move up. So 5 faces are going up, one is at the top, one is at the bottom. So there are 7 in short faces for the pentagonal prism. Isn't it right? Just count now. 1 at the bottom, 1 at the top, and from each side, as there are 5 sides, 1 2 3 4 5 sides, each side is moving upward, creating one face, right? So 5 sides will have 5 faces, one is at the top, one is at the bottom. In short, there are 7 faces. Now let's think about the vertices. This is the prism, means at the top flat portion is there, at the bottom flat portion is there. It's a pentagon, so 5 points will be there up, 5 points will be there at the bottom. So 5 plus 5, 10. So 10 vertices there will be there for this diagram. And now for the edges, same thing will move up, like 5 edges up, because it's a pentagon. 5 edges will be at the bottom, and from vertex to vertex, one edge will move up, right? So 5 edges are moving up. So in short, we have 5 edges at the top, 5 edges at the bottom, 5 are moving up. So 5 is a 15. So in short, we have 15 edges for this pentagonal prism. I hope I'm making it very clear to you all. So in short, we have 7 faces, 10 vertices, and 15 edges for pentagonal prism. Boys and girls, try to be with the habit that just by listening to the name, you will be able to make out how many faces, vertices, and the edges are there. Now boys and girls, we are at the ending part of the lesson. Now it is time to check your knowledge. Here is the list of 3D shapes, and accordingly you have to write faces, vertices, and the edges present in that 3D diagram. Do not forget to mention the answers in the comment section below. Till then, see ya, take care, and bye bye.